Okay, we have this disclaimer that if you don't want to be seen in the screen share, in the live streaming, just don't switch on your video or audio. And yeah, I think we are ready to start. Andres, you could now do the introduction.
Yeah, sure. Hello. So it's my pleasure to introduce my colleague Duncan Coutts, who is a partner at Well-Typed, and he's around in the Haskell community for many, many years. He's been doing all sorts of things, from partial evaluation over like helping with the Haskell infrastructure, developing on Cabal install and on Hackage, to working on various commercial Haskell projects. And he's currently spending most of his time working on projects for IOHK, helping developing the Cardano cryptocurrency. And he's going to talk today about a topic that is very important in a lot of projects, but nevertheless slightly annoying from time to time, namely logging. And I think he's going to try to explain to us how we can achieve to have proper logging without getting grumpy. So
yeah.
And just one minor point that was not clarified up front. How do you want to have your questions asked? Do you want to have them asked in chat and I forward them to you, or do you want that someone can just simply unmute himself?
I'm happy with people to unmute and interrupt. I'm happy to do this as a kind of more conversational thing.
Perfect. Additionally, I will monitor the Slack if something pops up.
I've also got the Slack channel up, so I can also, at least I hope I'm in the right Slack channel.
Okay, then.
So people ask questions there. But yeah, if people are on the actual call, then do feel free to just chime in, interrupt. This is not a talk where I've done huge amounts of preparation and thinking about exactly what I say in what order. So feel free to just chime in.
Okay, perfect. Please start.
Okay, so yeah, as Andres said, this is about an annoying topic. At least it's typically annoying, and basically I want to share my experience of what I've found to be a genuinely better solution to what has historically been an annoying problem. So I want to start with going through why is this problem, why does this make us grumpy, identifying what the problem is, and then I want to show you what I think is actually a nicer way of doing this. Now, I'm not trying to sell any particular concrete library, but I want to sort of say that this idea, I think, I want to promote this idea, and hopefully that'll be useful to people. Okay, so let's start with let's start with a rant. Why is logging so annoying? Why does it make me grumpy? What is the pain? So logging, it sometimes is a necessary evil in some ways. You have to do it in real applications that do non-trivial things that are long running, etc. And logging tends to, in my experience, and this is probably true for most people, you tend to find that it just clutters up your nice code. Your application code, suddenly when you add all this logging, becomes cluttered with all this just extra stuff. And that's annoying. In particular, it's really annoying when you come in to write library code. You want you to write your library code in this nice, reusable way. I mean, that's why you write libraries. And adding logging tends to be kind of opposite to that desire to make your libraries nice and reusable and not make too many assumptions about their context so they can be used in many different places and ways. That adding logging tends to work against the ability to make your code reusable. It tends to conflict with modular designs. I'll go into each of these in a bit more detail. And sort of finally, borrowing Simon PJ's one of his favorite phrases, it has a low power to weight ratio. We like things that have a high power to weight ratio. I'll get to more about what I mean about those things. So here's a snippet of some real ugly code. this is from an old version of an application that I was working on. So okay, I mean, the point here is not to understand this code. I mean, it's a snippet. It's a horrendous snippet of code from a horrendous code base. But the point to the key point here is, we've got some stuff that's going on, and then we've got interspersed within it all these logging things. So in this case, there's two logging entries, but each of them is non-trivial. It's lit. I mean, for starters, it's just taking up space. Like approximately half of the code here in this snippet is just logging code. So it means I can fit less of it on the screen, which means it's harder to read, and I can fit less of it in my brain. And that's just a simple annoying thing. We're mixing in at this point in the application all these details about formatting strings, formatting actual messages, and that drives me crazy. I hate that. Maybe that's just a sort of a visceral emotional reaction. That's not necessarily a rational thing, but we can come back to why is that bad sort of from a rational point of view. But I hope you share my sentiment that this is kind of this is ugly and annoying, and doing all this detailed sentence construction intermixed with your application logic is just awful. More subtly, we had to make a decision right here at this point in the code whether how severe some messages. Our logging infrastructure requires us, we've picked some logging infrastructure, and it requires us to make decisions about whether things are informational, critical, warning, debug, and we have to make a decision about each of those things. At the point in this code where we are constructing these messages, and that. Again, it's slightly hard to explain why is that a bad thing. You don't always know. You don't always know the answer in this local context. What should be the severity from the? It's kind of the wrong place. It feels like to be deciding this severity, but we're often forced by our logging libraries to make that decision. Right at the point at which we are creating a log entry, and often, although not in this concrete example. We have to pass in extra information, extra context that is only needed for the logging, but is not needed for the application logic, and that's just annoying. All right, so that's the sort of just grumpiness about cluttering up the application code. What about this library reusability issue? So if you were to add logging into a library, you suddenly face the problem of, well, which logging library should I be using? And already you hit like a kind of roadblock, because if you want to make a genuinely reusable library, there's hundreds. It feels like that's not really true. There's lots of logging libraries out there, decent ones, and different people have different opinions about which one's best, and different applications call for different kinds of logging, different information you want to log. Some require just severity levels, some need to have like privacy levels, some need verbosity levels. There's genuine, it's not just a matter of preference and reasonable people disagreeing, but there's also genuinely differences between applications that need different kinds of logging. So you don't want to have to make that choice up front in a library, because a library ought to be reusable in any of those applications where they need different styles of or different details of logging. So, and you don't want to have to add, these quite severe concrete dependencies. I mean, some of the libraries are structured in a way that, there's kind of backends have more dependencies than a kind of core library. So you might be able to depend on, cartip core or something, or whatever core, and not depend on, details of logging backends, but you still kind of tied yourself to one particular logging library, one particular logging interface, which tends to have lots of dependencies. So how do you deal with that? You're sort of forced to, if you want to make it reusable, you can't really use any of the existing libraries because each of them provides their own specific interface. Yeah, and as I said, different applications need different choices of these things. And how are you going to actually build your log messages in a library? You don't want to be using, strings. Different applications are going to need different string messages. I mean, if you want to, some applications want to have string messages, some want to have a structured log output. You can't. How do you make a universal choice if you have to pick a concrete, log item? And what about, the application may have context that it would like to include in the log entries that are produced by the library. So how do you manage that? So it's not just the library producing log messages, but there's additional context that may need to be included. So yeah, the logging and libraries don't mix very well with the current style of logging interfaces, logging libraries. There's also, I was saying, a sort of conflict with design modularity. One of the things with modularity is about making sure that not every part of the code depends on every other part of the code. Bits of code need to not know about their context so that they can be reused in many contexts. So, okay, here's a sort of slightly trivial example, but it illustrates, I think, the bigger point. So imagine you have got some inner layer for talking to writing a protocol that talks to a single remote peer. So that remote peer is implicit. Right? Let's say you've got a socket or a handle of some kind, or or it might be like a database or whatever. Something where you're talking to one remote thing through a handle. And then you've got an outer layer. So the inner layer, only has to think about talking to one peer. Right? This is good for modularity. Nice designs. And then you've got an outer layer which manages collections of doing that for many peers, right? So the outer layer knows about the fact that there are many such things, and the inner layer only needs to know about one. So in particular, quite often, the logic of the inner layer doesn't need to know like the identity of which peer it's talking to. But for logging, that's exactly what you need to know, right? All the things that would happen in the inner part that are interacting with, where you're logging interactions with some remote peer or some database or whatever it is you're doing. Those log items in the end, you really want to say, well, which peer or which database or which whatever was I actually interacting with? So you need that context to be in the log items, but you don't want to pollute your design by passing in unnecessary extra information. So that's a kind of simple example, but I think that same problem, I've seen it many times, that the need to have the appropriate context in the log entries, in the log items, conflicts with the desire to have smaller components, smaller parts of your code not know about things, not know about the context in which they are in. So yeah, in this example, you'd have to unnecessarily pass in the peer ID into your into your sort of inner part, where it would normally just need to have some handle. Okay, and this is this slightly more general point about sort of what do we actually get for all this? We sprinkle all of our code like this with all this logging stuff, and what do we get? Well, what we get is just logging, but right, in a real application, it's not just logging that you need. You need like runtime monitoring, metrics. If you're observing some long-running server, typically there's lots and lots of metrics that you want to be observing about it, or timing information about how long it takes to do certain actions. Think about just an ordinary kind of web service component that's long running. There'll be various internal metrics about its state, its performance, or timing information about how long it takes to do certain key internal things. That this is not about micro benchmarking like as you're developing it, but for runtime, operational, kind of operations things. You want to be able to sometimes see how long certain things are taking. And this logging stuff doesn't buy us any of that. We've had to sprinkle our code full of all these log messages, but yet we still have to kind of do the same thing again when we want to add metrics and monitoring and other kinds of runtime introspection of what we're doing, because that's what logging is. It's sort of some kind of runtime in poking into the internal details of what the application is doing to find out what it's doing. And logging is not the only thing you want to do for that. So yeah, the typical approaches to logging only bias logging and don't give us any of these other things, and we have to then go and use EKG and or other things, and then we get even more cluttering and doing sort of similar things, but doing them again and doing them separately. So that's not very satisfactory. So that's the sort of the pain, the grumpiness. What can we say more generally about sort of what's wrong here? What's the cause of all this grumpiness? And I think one of the key things is that we're doing too much at the logging site. We're having to decide, for example, severity. We're having to decide, everything basically at the point in the application code where we're producing the log message. But that, I think, doesn't really correspond to where a lot of that context comes from. So we're having to then plumb all this information through to these call sites, these logging call sites, that doesn't naturally come from that point in the application. It comes from sort of somewhere else in the application. It's just that for the purposes of producing the log messages, we've had to add all this extra plumbing, and that plumbing makes clutters things, and that breaks the modularity and the rest of it. So yeah, we're passing in often extra context into that logging site. Like, you could even say the severity is kind of context information. You need to know something about the application, what it's doing, to say whether something is critical or a warning or whatever. But so things like, which peer am I talking to? Which database connection am I using? That's clearly sort of context information. And a sort of another general observation here is that, yeah, with similar ideas, that by constructing the final result at the logging site, we don't allow for different interpretations in different places. So this is about the library question again. Different, a library that you want to reuse in many applications may need to produce log items, but different applications will want to handle those differently, interpret them differently, like just trivial things like different severity levels or different levels of verbosity or different ways to render the same thing, rendering it to different logging backends, or structured versus unstructured, these kinds of things. So doing everything at the logging site doesn't allow for those different interpretations in different applications. If we had to construct the final completely formed log item, structured or unstructured, whatever it might happen to be. So how can we solve this? I mean, I think a lot of this is this kind of context problem. How do we, if the problem is that we're deciding too much at the call site and there's context, how can we do better with getting the context into the log messages, but without messing up our application code or messing up the structure of our code? So there's various ways just in Haskell, just in general, this is not specific to logging, about how can we pass extra information into somewhere or include extra context, augment something with additional context. So the most straightforward way is just to pass extra arguments. So augmentation via arguments. So the example here is in the outer code. You just pass the context, which is the variable c here. We just pass it in to the pass it into the inner code as an extra argument, extra function argument. Very straightforward. And then in this example, doing our logging, making use of the extra context at the call site. So that's the problematic version. But that is a standard way to augment things with extra context. Just pass it down by adding extra function arguments. We can also, as a general technique in Haskell, functional languages in general, augment results. So instead of passing extra information in, you can sort of alter the information as it bubbles back up. Right? These are two completely standard tricks. So if you didn't need to do things differently on the inside depending on the argument, and you just needed to sort of annotate the results that you get with that context, then you can do that by just constructing an annotated result, like in this trivial example, pairing things up, but more generally using custom types. So we annotate the result with extra context. And that way the inner code didn't need to know about that context, right? So that's a difference. In the previous one, we passed that extra context in, which is fine if the function actually has to depend on it, but it's annoying in this case where all you needed it for was a logging. Whereas this style says the inner thing doesn't need to depend on that context. We can simply annotate the result with the context. And then a variant on the first idea really is that if you're already in a situation where you are where your inner code is given some function, then you can pass extra context in via that function closure, provided the inner code doesn't need to actually depend on it, need to depend on it in a logical way, analyze it, inspect it. So in this example, the inner code is given a function from something, and it calls that the inner function calls this function on the inside somewhere, and then in the outer code, we simply, to pass in extra context C here, to make use of extra context C, we just pass in some function that makes use of that context but we don't need the inner function to know anything about it. Simply the closure that we pass in captures that context from our outer environment and makes use of it. So that only works in the case that you've got some function that's already being passed in, and it only works in the case that you didn't need the inner thing didn't need to know about it. But that's exactly the case that we have here in this kind of complaint grumble about logging, where you want to annotate log items with extra information, but you didn't want the application code to actually depend on it. It was so yeah. This is a trick that can help us. So what's the big idea? And I should say this is not like my idea. I'm not trying to claim glory and credit for it, but I want to tell you why I think it really is a good idea. So we take this a completely radical and extreme from the other end of like all these logging libraries, where they're typically defining log items that tell you severity and this and that, and they have all the details, and all of that information has to be done at the log site. The sort of radically opposite approach is that we trace typed values, and we trace only those typed values. So we don't say anything about hierarchical named log items. There's no severity specified at the call site, no strings, no messages that we construct. We just trace typed values in the application code. And then we have a mechanism for transforming those typed values that we're tracing. And this in particular, this is what allows us to add context. And it allows us to convert from application types, types that are specific to our local piece of code in the application, into these more general, or into these buckets of untyped logging information, or not untyped, but kind of universal types like strings or structured log items. The kind of types that are defined by your logging library. So we have a mechanism for transforming these things, and then the interface, we end up with a logging interface that the application code uses, which is absolutely tiny. It's really very minimal, and this means that we can have almost no extra dependencies in the application code. The only thing we have to depend on is this trivial little interface, and then this can be instantiated with any logging backend that you like. And I'm not going to opine at all in this talk on favorite logging libraries. Pick your own, whatever is appropriate for application, whatever suits your preferences. So what does this look like? Here's the tiny core API. A tracer is just a new type wrapper around a function from A, some typed log item that we want to trace, to an action in a monad. That's it. So we can trace with a tracer. So we can trace a log item with a tracer by just calling that function, unwrapping it and calling the function. And we can transform these tracers using contramap. If you've not seen contramap before, that's on the next slide. So examples of primitive tracers in this style would be, well, a null tracer is an action that ignores its input and does nothing. Stood out tracer might be just put stolen. That's probably concretely not a great idea because of concurrency interleaving, but you get the idea. So that obviously, and we're parameterizing here over the monad so that it is possible to switch between monads. I've not included in this core API here like a natural transformation function, but it's relatively straightforward to do. So you can move between different monads. But this concrete example, put stolen, would be obviously be IO. Okay, so let's look more at this contravariant business, because that's crucial to to this thing of saying we need the mechanism for transforming trace values. Well, the contravariant is that mechanism. So if you've not seen contravariant before, this is it. This is the type class. It lives in base these days. It's a relatively recent addition to base, but a very sensible one. And it's like fmap and it's like functor, but the other way around. So if you like, functors are things that are, and if you want to sort of, this is not a mathematically sound way of thinking about it, but it's a useful way to remember, I think. Functors are things which are sort of parameterized over their outputs, if you like, or what they contain. Particularly if you think about, like a function as a functor, they're parameterized over the output, and then fmap transforms what that output is. Like think about something like IO, IOA. Fmap over that is transforming the output of that action. Whereas you can also have other higher ranked types which are parameterized over their input, and then in that case contramap is for transforming over the input. So in the example that we had, where is it, back here again, our tracer is wrapping a function where its input is the type parameter. So our tracer of A is a functor-like thing, but it is not that the A does not correspond to an output, it corresponds to an input. So that's why it's a contravariant functor and not a, what's the other way? I'm not gonna, I'll get my category theory wrong. Anyway, this one's definitely a contravariant functor. So contramap is like fmap, but the other way around, it's transforming the input rather than transforming the output. Okay, we'll come back to the intuition for the contramap when we see some examples, if that doesn't immediately make sense. So let's look at how would we apply things like this in application code. So this is, I'm taking here snippets of real examples. So these are slightly bigger than examples that you might like to sort of trivially fit on one slide, but they are taken out of real examples. Okay, so the style that I would advocate here is that you in some module where you're doing something that needs tracing, needs logging, we are going to define a new data type which defines all of the local events and values that we want to trace. And so we just have a data type with a bunch of constructors, one constructor per event of interest, and each event then carries the values that are interesting at that point. And then we pass in a tracer to our actual application code, a tracer of that type. So this is not, we don't have to change any monads. This is not a monad stack style. or at least it doesn't require a monad stack style. You could do that if you like, bundle your tracer into your monad, but it doesn't require it. The simplest possible thing here is you just pass in the tracer, and the tracer is, let's say, of the type of the custom type that you define locally for that particular module or particular set of modules. And then within the body of these functions that get the tracer passed in, they simply call trace with, and they use one of the data constructors, selecting the values that are available at that point in the code. So we're not doing lots of transformations on, like with when we were building building trace messages or building log messages. We had to do all kinds of functions to select and transform and pick out the bits of the application values that were interesting. Here we just stick them in. So there's very little. The idea is as minimal as possible transformation that happens at the point of tracing. You just trace the values that are available to the application logic at that point, and that's it. So that means that we're trying the amount of sort of interference of adding this tracing should be as small as possible now. We're just passing them in as values, as parameters, as function arguments, and sort of simple one-line tracing. Hopefully that's a sort of low overhead as one can get it. So that was using trace with directly. Let's see an example. This same example is extended with one that uses contramap. So same example. We're doing something with DNS. Doesn't really matter what exactly. And so this is an extended version of the previous example. On the sort of very next statement, we're doing something with contramap. So the bit that I'm focusing on here is this with resource blah 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 contramap. So what's going on there? We're calling some some other DNS library, and it's going to do something which might end up with a DNS failure or an IO error. So we're calling our DNS library to actually do some DNS lookup, and it might give us a DNS application, a sort of DNS failure, or we might just get a Haskell IO exception. And this is being returned as this DNS or IO error data type here. So we've got the outer tracer we have is this custom local data type, trace local root peers. But the inner tracer that we want to pass to our DNS lookup code is only going to be tracing a tracer of this DNS or IO error type. So yeah, the interaction needs a tracer IO DNS IO error, and we're going to use contramap to lift one into the other, to lift the inner context into the outer context. The inner tracer, which is just dealing with a single DNS or IO error without knowing the context of like what it's looking up or the context of the local module that it's within, and we're lifting that into this local tracer type, which also includes we're annotating our DNS or IO error result with which DNS name were we looking up at the time that it went wrong. Right? So we're annotating it with the context, and that's exactly what's going on here with the use of contramap. We're taking our top level tracer from our outer context, and we're applying the extra context to give us a tracer for the inner context, which only deals with the inner thing, only deals with the inner DNS or IO error. So that's where this sort of direction of lifting becomes can be sometimes a little bit confusing, with the contramap being the opposite way around from fmap. I'll give you another example to help the intuition. So here's perhaps a simpler, easier to understand example for contramap. So we have a context here where we are doing something many times, across, in this case, many different peers. So in this particular case, we've made a decision for each of a number of different peers, and then we're going to act on those decisions for an individual peer. So again, it's kind of an inner and outer kind of example, where the outer is doing something many times, making use of the inner action. So in this example, the inner action doesn't need to know, the identity of the peer that it's dealing with. It has a state variable, so it knows which one it needs to talk to. We need to keep track of this peer for at the outer level for sort of tracking purposes. And we also want to include it into the tracing messages, the tracing values. But so the inner tracer here is, so at the bottom here we've got the inner tracer is going to have a type which is called trace fetch client state. But the outer layer wants to use a tracer that includes, which peer was it referring to. So we've got another data type which is annotating a data type with the peer. So the outer one is a tracer of a trace label peer with the peer data type and the same inner thing that we're trace fetch client state, whatever that is. So you see what's going on. The inner thing just focuses on its one little bit of tracing information, and at this point in the code where we are going from many down to one, we're also mediating the tracing to annotate the inner tracer that just deals with one thing to make it a tracer that deals with that keeps track of the fact that there were many things, there were many peers, annotating, labeling our inner trace values with the peer that was appropriate. And so here we're using contramap again. But note the direction, right? We have our outer tracer, this example here, client state tracer. This is the tracer value for the outer one, and it has the bigger type. And applying contramap gives us a tracer for the inner type. Why does that work out? Go back to look at the contramap. It's the direction of the arrow in the contramap. It's the A to B gives us an FA to FB. So an A to B gives us a tracer of B. It gives us a tracer of A from a tracer of B. So that's why this sort of might feel like it's backwards. Contramap applying this extra outer tracer constructor actually gives us, a tracer for the inner type, having started with the tracer for the outer type. Which makes sense in a way, remember, because it's applying the function to the inputs, not applying it to the outputs. So hopefully that gives you a sense of the intuition. It does sometimes take a little while to get used to. How do you then build this up? How do you make bigger, make use of this at a bigger scale? There's a couple different ways, but I think the simplest way is just to aggregate tracers. So if you've got, in these examples we've had data types that were specific to some local module or some collection of related modules, but for modularity we obviously need to be able to have many of those things, and the simplest way to do that is just to have each module or set of related modules define the tracers that are relevant to them, and as we go kind of up to the level of the application, we simply aggregate many tracers. And there's actually a product way and a sum way to do this, but I think the product way makes more sense. So the style here using records. So this is a snippet out of, again, a real application, same application. And there's actually like 15 of these things in the real example. So we just export that big record of tracers, and that deals with the problem of having to pass around like 15 arguments. You don't need to do that. Just Haskell is quite good at passing arguments. Records make that easy, so just use records. This style, what's good about this style, I think, is that it's clear what you're doing. That you do have all these tracers. It's just a product of them, and it makes it quite easy to pass different tracers, different concrete, instantiate this with different choices of tracer. So you don't have to trace every single one of these. We can, we gave the example earlier of a null tracer that did nothing. So it's totally okay for some component to have some debug tracers that you never actually turn on, and if you wanted to debug it, you'd have to go and change the code and change a null tracer into a real tracer. Okay, so how do we actually turn this into? There's a question.
There was a question in the Zoom chat.
Oh,
I'm not sure if you,
I've not been seeing the
that.
Zoom chat. I've been looking at this.
Yeah,
this Slack.
Me too. That's I also don't know how old it is. The question was, how about giving a name to something equivalent to flip contramap, so that the syntax does not look backward?
Let's see. So in the contramap, let's have a look at contramap. Is that what you want? Let's see. That is yeah, that is
Hello.
that flipped, isn't it?
Yes.
So
Can
yes,
you hear?
if you like it, you can use that style.
Well, the point is, yes. Well, yeah, you've got the combinator there. So my point is that, see, with tracer, normally with when you don't use contramap, you have tracer together with one of those data constructors of your event data type. But when you do use contramap, it looks flipped. Yeah, you have
I'm not sure it does look flipped in the end. I mean, it's
because
partly
you have
a matter of getting used to it. Because look at this example here. We the order of the constructor corresponds to the kind of function application order. Trace labeling with the peer is just applying that constructor to its inner thing. So in some sense, it depends on how you think about it. I mean, you can either sort of mentally deal with the fact that it was not the way around you first thought it was, but then you just sort of get used to that and it ends up looking perfectly reasonable. Or I guess you can, do the flip thing. I don't think I've really found I mean, this is a completely matter of personal choice.
Yes, certainly. This
I've
is
not
a
found
small little thing. Yes,
but
but in your earlier slides, you had tracer space, applied to.
Where was it? This one? No, sorry, this one. Here we are.
Yeah, there you go. Trace with tracer, and then you have your data constructor, and but with the contramap, you see it looks flipped, because then your trace local root failure is now in front, whereas trace local root waiting is after tracer.
Oh, I see. But in some sense, I mean, trace with tracer is actually using the tracer, whereas this is transforming the tracer. So this is really like the contramap is like a function application.
True, but so there will be people who will be programming, and it's like, they sort of like, just keep these, what's lowercase, what's uppercase, what follows, lowercase
you are
follows
absolutely welcome to use
uppercase.
the flipped version.
Yes. Okay. I yield the floor. Sorry.
No, it's a perfectly reasonable question. So okay, what was I was talking about so we'd got to the stage of like using it in application code, or at least the general idea, a snippet of it. How do you actually then turn that into real logging in the end? So pick your favorite logging library, pick your favorite logging backend. As I said before, I'm not going to, there's many reasonable choices, and different applications would need different choices. So there's no need to have religious wars over which one is better, because it now becomes really easy to change. It's not something that affects your entire application. It now can become something localized. So then we have to mediate between our choice of our favorite logging library. Okay, I said I'm not going to pick winners, but here's an example with cartip. Just an example, where we have to mediate between our concrete logging library and whatever notion of log output it has, and we have to turn it into some kind of top-level tracer. So in the case of cartip, you would probably end up doing something like this. You would have a tracer of a cartip item. So that fits the tracer interface, and the implementation of that tracer is obviously in terms of calling cartips, scribe, backends, whatever, for actually emitting items, logging items. So okay, we've got our top-level tracer implementation, and now somewhere near the top level of our application or component, we need to define a whole bunch of functions for transforming the traced values, the application typed values that we have in our aggregated to our bunch of top-level tracers. We've got to transform those into the sort of universal type of the log items for our chosen logging backend. Now, what's good about this? We're now at sort of relatively near the top level of the application or component. So we know all the context at this stage. We know what we know in principle, the relative severity levels of things. If we want to have a notion of verbosity, we can do that here. Like you might have a configuration file that tells you, not just the severity levels, like you can filter out, like logging libraries typically have a mechanism to filter out lower severity things depending on configuration. Some applications need a different dimension of being able to have different verbosity levels for the same severity levels. So you could easily do that here. You've just passed to get the verbosity in from a config file, and your functions that transform the typed application values into log items can make use of that verbosity. We can easily turn tracers on or off. Either like statically or kind of like once based on configuration by either passing in the null tracer or not, or a real one, or we can do that in principle at runtime. We can have it. It is possible to implement a tracer that like depends on an IO ref, and so you can change at runtime whether it's emitting things or not. Even if your logging backend itself doesn't have that capability. I mean, you may turn these, you may have these filtering things, as a capability in your logging backend, which is fine. But if you don't have that, or even if you do, it can be more efficient to, filter things as early as possible by turning them off in the tracer, rather than waiting until you've gone to the effort of building your generic log item and then discovering afterwards that you wanted to filter it out. So there's some possibility with this style to sort of push, for efficiency reasons, push some of the things forward without having to change the structure of the code. And obviously we can select the bits that we need. So we don't have anything where we would need to do transformations on the application code to select out the bits that are interesting to emit into structured or unstructured log messages. We can do that in these transformation functions. So this is a style where we basically pulled, instead of scattering our log transformation functions throughout the code base, like we did like you saw in the very first example that was making me grumpy, we've kind of brought them all together. And I think you might say, oh, that's very monolithic, but you're doing this at an appropriate level, some appropriate level in your application. Or which may well just be the top level in a program, and I think that's perfectly reasonable. There are quite a lot of advantages to having it localized. You can ensure consistency much more easily that way than when it's scattered throughout the code base. Okay, so I sort of ran out of time when I was writing my slides here, so I'm going to sort of waffle a little bit more. But the question here is this really actually better? I think the answer is definitely yes. I mean, I have used this in a real application. The snippets you saw are from a real application. It's like hundreds of thousands of lines of Haskell code, and it genuinely allowed all of our application code, the interesting bits of the logic, to be relatively lightweight on logging. It's not cluttering, and in particular, it's not adding dependencies. It's not adding these heavyweight heavyweight dependencies. And logging backends often can be quite heavyweight, because there's really interesting, useful things you want to do about sending things off to Prometheus or remote logging servers and services. There's a whole bunch of interesting heavyweight backends that you actually want to use. But this is very cleanly separated those out. So your application can still have quite nicely structured dependencies. It genuinely seems to resolve this problem with modular designs of not wanting to pass in too much information. Now, on the on the reusable library code, I mean, you do depend on this tracer interface, but that is very, very minimal. That's, as it's only slightly more code in reality than was on my slide earlier. It's really small, and I would like to put that up on Hackage. Hopefully, I'll do that soon. But even without that, you don't. I mean, in the worst case, you don't even need to have that library depending on that library as an external thing to use it in a library. You can just define this kind of thing locally, because. So, I mean, I think a good thing about this is that this style is you don't have to change the whole world to start using this style in particular parts of your code base in a library, say, because you can simply use this contra tracer interface, and if you're making use of it, and if the rest of your application is still using a big fat logging monad, you just pass in your logging action as the tracer. So you don't have to switch your whole application over to this style to start experimenting with it, or to start using it in libraries that you want to be reusable. On this question of power to weight ratio, I didn't have time to go into it and write slides for it, but there's actually a lot more that you can do with these tracers, because they're no longer specific to logging. In fact, the name tracer is suggestive of the fact that it's not just logging. We can use these tracers for multiple purposes, and this is what gives us a high power to weight ratio. So we can obviously do logging. That's really what I've been talking about. But imagine using EKG for runtime metrics output. Excellent library with lots of useful backends, like, as I said, Prometheus I mentioned earlier, one that we've used for aggregating metrics across distributed applications. So with EKG, you want to be able to turn certain observations within your program into numeric or other kinds of or distribution sort of metrics, and you can implement that fits the tracer pattern, because it's just being given a value at a particular point in the program and doing something with it. So it totally fits to have use the same tracer, the same probe point in your application code to be used both for logging output and also for updating EKG metrics. And more than that, you can actually use these exact same tracers in testing code. And this is something that we've done within the application that where we've used this. In many places, we're able to use these probe points into the application logic to as part of quick check tests. Because sometimes, in complicated code bases with lots of I/O or concurrency or whatever, it's not just about testing results and outputs, but did you see certain things happen in the right order, or did you observe the right values at that trace point within the code? You can use these trace points in tests to give you that, and that gives you now a lot more utility for the same amount of invasive code that you've had to insert into your application. And it also makes you think a little bit more about what it is you're tracing. What is the property? Could you write any property about what you're tracing? Like, is there some state machine that describes the sequences of events that you would see through your tracers? Create this, do something here, and then it always has a corresponding closing event. It makes you think about that. Should I include a closing event so that I can write a property that checks some state machine property? It makes you think a little bit more clearly about what events are you really tracing. So that's it. That's the idea. Our experience of using this in a real application is that it works really nicely. I'm not going to say that our logging backend was the most awesome, but it doesn't matter because you get to pick. You get to pick your favorite logging backend. You can use Cartip if you like. You can use something custom. You can use whatever, fast logger, whatever is your favorite.
I think we have another 5 minutes for questions. So since it sounded like you finished
Yes,
the
I'm
call,
done. Yeah, so
I will
questions.
open the round for questions. Do we have any?
I have a question, which is, do you find that you end up having to pass around a lot of these tracer arguments explicitly? And have you thought about something like implicit parameters as a way to reduce the overhead of that, or do you just think it's not?
We do have to pass tracers, but typically it's only one. In any particular piece of code, it's typically only one, because the places where you aggregate them, I mean, I would typically go for the sort of model of like, by the time you get to 3 tracers, put them in a bundle in a record. So I think if you would look in the code base, you would find probably the maximum number of tracers to get past at any one point would be like 2, but typically it would be actually just 1, or it would be a record, a bundle of such tracers. So my general view is that functional languages are rather good at passing arguments. So don't be afraid of just doing that. It's really the simplest thing. Yes, it shows up in the type, but if you use implicit arguments, it shows up in the type as well. Does it really save you? I think it's simple and clear to just pass them as arguments. It's not that bad. But that's a sort of philosophical thing. Yes, you could bundle these things inside your monad. You could bundle them in implicit arguments. You could do that. Yeah. That's a matter of personal taste.
Do we have another question?
Someone ought to ask, when is this on Hackage?
Oh, yes, I have another question.
Yeah.
Go on.
Yeah.
So looking at the tracer type, which is a new type, have you considered dispensing with it entirely, which is just to use the raw, A to an M of unit? Does that even buy you anything? Have you thought of whether you even needed that?
I think it helps you
type?
with documentation and error messages and things. I'm not going to say. I was about to say that maybe it means the type class instances don't work out so well, because you by making this a new type, you can definitely obviously get contravariant directly. But maybe those things work directly on, and monoid and everything works. Well, monoid doesn't matter.
Not really.
It's
the function instance, right?
The function instance for contravariant would definitely work. Yeah.
Yes.
But I think there's an advantage to using the new type, which is just for documentation, because you can look at it and go, oh, that's a tracer. Right. Whereas if it's like some value to, IO of unit, it's much less clear to the reader what's going on.
What is the footprint like in terms of your code base when it comes to this new type wrapping and unwrapping of the tracer?
You don't have to do the wrapping and unwrapping in the application code ever. You only have to use trace width, contramap, and occasionally you'd have to use like the natural transformation lift if you're moving between monads. At the very top level of your application, you've got to define one of these tracers directly in terms of your logging library. But then for other things, you generally can just use contramap to transform the values. Occasionally, when you want to do something sophisticated, you might need additional combinators, like if you need to do conditionals, runtime conditionals, or define new primitives like turning a tracer into an EKG metric or things. But that's typically stuff you do at the sort of application kind of top level, rather than within your, within the kind of logic of your application. If you see what I mean. So I think the overhead in your application code is very light. I think that's the key thing, and that's I think that's the right trade-off, to move all that grungy stuff into kind of one place in your code rather than spreading it through the logic of your code.
Okay, fair enough.
And what about the memory footprint? So if you produce a lot of messages, do you have any buildup of things?
No, these things are synchronous, or at least the action is synchronous. What then happens within your logging libraries obviously depends on your logging backend. So this does provide, as I said, the opportunity to rather early in the kind of pipeline of the generation and transformation of log messages to filter things out. So not only can you pass in null tracer for ones that you're genuinely not using in a particular context, but you can also construct tracers that, like I said, make use of runtime information to decide whether to filter things out early, before they've even bothered to transform them into, the universal representation of your log items. So I think on the efficiency front, there's certainly the opportunities to do things efficiently. And whether there's a buildup of memory or whatever really comes down to your choice of logging backend.
Okay, great.
I mean, if you use the null tracer, there's almost no overhead. There's a runtime dispatch to calling some function that does nothing. So you can make it as low as that. That's the sort of the minimal limit.
There was one question in the Slack chat.
Yeah. Okay. So line numbers, file names. That is a good question. So the one, the sort of the easier one to deal with is kind of application context, where some logging frameworks like to be able to give hierarchical string names to components, subcomponents, and that is genuinely useful for helping to at runtime filter out, allow operators to configure very detailed filtering and routing of logging messages, having some hierarchical naming scheme. The contramap makes it easy to add that kind of hierarchical naming, of course. But adding line numbers and file names, yeah, that would require a trick like the assert or whatever, where we're using something at the call site, and then it's true, you're not just tracing application values, then you would be tracing something with a richer type. So that is harder to do. Yeah. But there's other things which are easy to do, like time. It's easy to take a timestamp at the point at which the trace message is created. But line numbers and file names, that is more of a tricky one.
Okay. I think we are over time. You will probably answer further question in the Slack chat.
Yes,
I assume.
happy to do that.
Also, maybe appear in one of the break rooms. I would ask everyone to unmute, and so that we can clap and thank you again for this perfect talk. And it was a pleasure to listen to you. And thank you.
Thanks, everyone.
Thank you.